Okay, good morning, ma'am. My name is Kiroshni. Today I'm going to present about case study presentation DFN 40223 fiber optic communication system. Okay, let me introduce my member of group. Myself is Kiroshni Kamraj, Haripriya Perisami and Yashwindran Devarajan. Okay, for the question 1, explain the light emitting diode LED light source in optic communication system. In a fiber optic communication system, an LED is used as a light source. It works by converting electrical energy into light energy. The LED light emits light in the form of photons which are then transmitted through the fiber optic cable. This light carries information in the form of digital signals, allowing for high-speed data transmission over long distance. LEDs are commonly used in fiber optic system due to their cost effectiveness and reliability. Okay, list three types. List three types of fusion splicer technologies that available nowadays. First one is cladding alignment fusion splicer. Cladding alignment fusion splicer aligns fibers based on the outer cladding instead of the core. This method is faster than core alignment but may result in higher splices loss, especially in single mode fibers. Second one is fixed V-groove fusion splicer. Fixed V-groove fusion splicer used a fixed V-groove to align fibers for splicing. While these splicers are generally less expensive, they may not provide the same level of precision as core alignment or cladding alignment splicers. And the last one is core alignment fusion splicer. This type of fusion splicer aligns the core of the two fibers precisely matching their core positions. Core alignment splicer use advanced imaging system and motors to align the fiber cores accurately. And the last one is list six procedures during handling ARC fusion splicer. The first one is environmental considerations. Ensure the splicing environment is clean and free from dust, moisture, and other contaminants that could affect the quality of the splice. And the second one is electrode inspection and cleaning. Regularly inspect the electrodes of the fusion splicer to ensure proper performance. Contaminated or damaged electrodes can lead to poor splicing results. And the third one is fiber preparation. Properly prepare the fiber ends before splicing by cleaving them with a precision cleaver. The quality of the cleave directly impacts the quality of the splice. And the fourth one is alignment and fusion. The alignment process is crucial to minimizing splice loss. In the fusion process, once proper alignment is achieved. And the fifth one is splice protection. Apply appropriate protection to the splice point, such as a heat shrink sleeve or mechanical splice protector, to ensure the long-term reliability and durability of the splice. And the last one is post splicing inspection. Inspect the splice using the splicer's monitoring system or an external inspection tool. Verify that the splice loss is within acceptable limits and that there are no visible defects. Okay, for the question 2 and question 3, my teammates will be present. That's all from me. Thank you.
My name is Haripriya Parisame. I will explain about the question to Madam, which is identify three types of testing that can be performed in fiber optic cable. The first is optical power testing, which is this involves ensuring the power levels of the optical signal transmit through the fiber optic system and is ensured that the power levels are within the specified range to ensure reliable and efficient transmission. And the second is optical loss testing. The testing is performed to measure the amount of signal that lost across the fiber optic cable. It high insertion loss which can degrade the performance of the system. And the last is optical time domain reflectment theory, OTDR testing, which is the goal of OTDR testing is examine an optical fiber properties such as length, authentications, splice loss, and the position and degree of any place, such as bends, breaks along its length. Second question is B. Figure 2b shown an optical time domain reflector OTDR display for 1 minute duration of a fiber optic system. Interpret displayed event labeled A, B, C, D, E, and F. The A is source connector and the B is splice and the C is connector, D is bending, E is crack, and the last one is end of the fiber optic. That's all from me. Thank you.
Next, I would like to present question 3. A. List 4 testing equipment used in fiber optic system. There are 4 equipments that we'll use in fiber optic system. The first one is optical time domain reflectometer, which is called OTDR. The next one is light source and power meter. The third one is visual fault locator, which is called VFL. The last one is chromatic dispersion tester. Let's move on to B question. The transmitter power launched into an optical fiber link is 1.5 megawatts and the fiber has an attenuation of 0.5 decibels per kilometer. Determine the maximum possible link length without repeats, assuming lossless connectors, when the minimum receiver power level required at the detector is 2. First, the transmitter power launch is 1.5 megawatts, fiber attenuation is 0.5 decibel per kilometer, and the receiver power level is 2. So first we have to convert receiver power to megawatt. So we have to do 2 times 10 negative power negative 3 megawatts and it will equal to 0.002 megawatt. Second, we have to arrange the optical power budget equation to solve for the total loss. The total loss is 1.5 megawatt minus 0.002 megawatt equals to 1.498 megawatt. Lastly, the formula for total loss can be applied to determine the longest link length possible without repeaters. The total loss equals to attenuation times link length. So the formula for solve link length is link length equals to total loss divided by attenuation. So the link length is 1.498 megawatt. So we should divide it by 0.5 decibels per kilometer. So the answer is 2.996 kilometer. That's all from me. Thank you.